everyone, so today we will solve another topic of fluid mechanics, chapter 3, total hydrostatic force on surfaces, from the book of Eunice and Gel, John Simbala 3-102. So consider a large cubic ice block floating in seawater. The specific gravities of ice and seawater are 0.92 and 1.025 respectively. If a 25 centimeter high portion of the ice block extends above the surface of the water, determine the height of the ice block below the surface. So in our given figure, the ice block floating in the seawater with a 25 centimeter high portion of the ice block extend above the surface of the water. So we are going to solve the height of the ice block below the surface of the water. So our given value, the SG of ice 0.92, the SG of seawater 1.025, and the height 25 centimeter above the surface of the water. So the formula we're going to use is the buoyant force equals to specific weight times the volume displayed. We will be using also the volume of cube equals S cube. The specific weight equals density times the acceleration due to the gravity. Since we have the value of specific gravity, using the formula specific gravity equals the density over density of water cross multiply. So we have this density equals the density of water times the SG. So we plug in the density to the equation of specific weight. We will have this SG times the density of water times the acceleration due to the gravity. So here in our solution, buoyant force equals to specific weight times the volume displaced. Then Sg of ice times the density of water times the acceleration due to the gravity times the volume displaced equals to Sg of seawater times the density of water times the acceleration due to the gravity times the volume displaced. So here, plug in our value, the Sg of ice 0.92 times the density of water 1000 kg per cubic meter times the acceleration due to the gravity 9.81 meter per second square, and the volume of the ice from the S cube. So the side of the cube is h plus 25 centimeter. Since the same measurement, we will have h plus 0.25 meter cube as the volume of the cubic ice block equals to the density of seawater 1.025 times 1000 kg per cubic meter times 9.81 meter per second square times the volume of the seawater h times the area h plus 0.25 meter per squared. So here we can cancel out the same value on the other side, 9.81. And also we can reduce the height h plus 0.25 cube to h plus 0.25 meter squared. So we will get 0.92 times the 3 minus 2. So we have the height plus 0.25 meter equals, we only have 1.025 here and the h, the other side. So 1.025 h. Then multiply 0.92 times h plus 0.25 meters. So we have 0.92 h plus 0.23 meter equals to 1.025 h. Then combine like terms, 0.92 h to 1.025 h. We have this 0.105
h equals 0.23 meters over 1.05.
So we have 2.19 meter. Therefore, the height of the ice block below the surface is 2.19 meter.